is pretty nice. I'm just going to share this link around, and then we'll be able to begin. I just hope I don't lose the connection halfway through, because I got 50 megabit connection, which is half decent, but I'm streaming at a 6000 bit rate. I'm no expert on that sort of stuff, but I hope that's not going to strain the network too much. Okay, so I can't believe I didn't think to do this before, because setting it up this way is cleaner, right? Because I got access to all my terminals here, you can see that, and you know, it's pretty good, because it means I can you guys can see what matters rather than what doesn't, so I can target it to you guys a lot better. Okay, let's start this. So yesterday's stream, you'll notice how I ran into a problem. I fixed that problem off stream, guys. Sometimes when things get a bit difficult, I come off stream and fix them myself. It's just easier for me sometimes to do that. You know, when you know someone's watching, sometimes it's a bit hard to solve problems. So just to demonstrate what happened last stream, let me quickly show you that. Okay, so when I do DNP host, you'll see, let's check you guys can see that. Yeah, when I do DNP host, right, hold on. It's showing the same window. I didn't realize that was the case for you guys. Let me just change this one a minute. Yeah, there you are. You have to bear with me with that stuff, because I haven't configured the stream like this before. You need more editing. Thanks. Why? Alright, oh, answer that, I wanna know. Right, so we have DMP host, and then if I try that again now, let me Control C this. Hello failed because the kernel module is already binded to a PID. Did you run twice? Well, we did run twice, so the kernel's completely rejected a second host now. Which is good. That's what we wanted. I could have made it so if the process crashes, we unbind. Personally, I'd rather not go down that road because then it means I have to destruct all the older related information, which I'm gonna do anyway when the module closes. But I'd rather just make it so, you know, if the process crashes, they have to restart the computer anyway. I'd rather just do that. It's just less chance for bugs that way, right? Alright, so you're talking about speed. Oh yeah, okay, right. Nah, this is my high. Thank you. I'd do this stuff for free if I was rich. Actually, what am I on about? This project is for free. Alright, let's unbind that. Let's unload that module. Once we've unloaded that module, then we're going to carry on with the development. Failed to bind to netlink, which is expected because we just unloaded the module. DMP kernel server, get hello response for PID response is fine. Send the packet back, which we do. Alright, so back on user land. If that is successful, and we successfully receive the ping response, why am I echoing there? Get rid of that. Then the client will start correctly. The base client will start correctly, which is expected, which then spawns the network thread, right? Alright, so that's all happy and done. Right, packet type, hello, send the packet. If it doesn't equal okay, fail to send initial ping packet, pretty simple stuff. Otherwise, receive the ping response, which confirms the kernel understood us. Alright, now sock -1, bind socket, and then we pass in a new socket. That looks fine. We bind to the socket, so that's fine. Message header is set up. All that rubbish there, yep, that's fine. So then what we need to do at that point is firstly get rid of sock equals -1. No, don't get rid of that, no. My mistake. Right, by here then, I thought the base was dealing with it, but no, this is purely Linux specific, so no. Right, up here then, once we have the client running, have we implemented run? Yeah, we have, good. So we use sleep 50 milliseconds each time. That's fine. What we need to do here now, we need to basically constantly check the new messages from the kernel. That's all we do. So we don't have to do anything else right now. That is literally it. We check the new messages from the kernel very frequently, and that is it. So all we're going to do here then, what I want to do now is I want to go back to the datagram protocol, and we're going to go back to the send message, and the we're going to go back to the send message and the send message. We'll go back to the send message and bind functionality. Okay, so that's fine. What we're doing there is we're basically copying the message back to us, which is fine. That's acceptable. I wonder why I'm not accessing it directly. Maybe there's a reason for that. I could access it directly, to be honest with you. I don't see why there would be a problem with that. I would save us one malloc each time, right? I don't know. I don't know the best way to do that, to be honest with you. Yes, I don't see the reason why we would need to be copying it like that, to be honest with you. Unless we plan to use it outside of this context, which we're not. So yeah, let's go back to the DMP kernel server. We need to create a method here. Alright, DMP kernel server binded to PID. That'll return true if we are binded to the user process, otherwise it won't. We need to lock this, obviously, for obvious reasons. Although rather than a lock, maybe I should have been using a mutex. Not a mutex, a atomic variable. Which I think there's a way in the kernel to do that. Hold on. It would appear so. So rather than this PID mutex rubbish, I'm just wasting. It's just ugly code, right? Let's just make an atomic T. I'll call it PID because I hope I can set it right like this. I hope so, because I'm not sure, to be honest, if I can set it like that. What is atomic T? Let's find out. Then I'll know. I'm gonna type there. Okay, right. Atomic T is a structure, so we can't just go ahead and set it like that. I'm looking outside of. You guys can't see everything I see, so when I talk to myself like that, I'm actually looking at stuff and forgetting you can't see it. So We're going to go atomic T PID, and we're going to set that in initialize instead then. Alright, I've just tried that now. So atomic set PID -1. Let's see if that works, and then we can go from there. So if we scroll back up to where we actually access that. Problem with working so late is it does get a bit difficult to concentrate, which is why I'm a little slow. Right, PID, and we want to set that to PID core. So I don't like to work too early either, because then it's just noise. So we do that, right, and we go atomic set PID, that's fine. And then what else am I missing? Right here, right. So is there an atomic get? I don't even know. So let's find that out. Okay, it's according to the docs that you guys can't see, it's atomic read, so we're gonna go with that. So we're gonna make that now. PID lock undeclared. Oh, of course it's undeclared. Right. This mutex lock. Guys, I made a big mistake. We do actually need the lock, unfortunately, because this relies on it. So we're gonna have to just erase all of that back to what it was. I'm really not bothered that I had to do that though, right? This is how it works when you're making projects. Refactoring is necessary. Right, DNP kernel server bind it to PID. You know, that's pretty self-explanatory. Yeah, so if the PID does not equal -1, we are binded. That code does look a bit ugly, to be honest. There we go, never mind. That's fine though, because we lock the PID mutex, we set binded, equals PID does not equal -1, which is simple, right? But there's no need for an if statement here. If the PID does not equal -1, then binded becomes true, otherwise false. Pretty simple stuff, right? Return binded, and we wanna put this in the. I forgot we're not in C++. Need to put void there. Maybe if I increase the standard, I won't have to. I don't know. All right, we put this here then. Put that there. Oh, Jesus Christ, bloody word! Right. I'll put that there, and then we can access that from the Datagram protocol. So this is pretty simple now. Watch this. All we have to do is say if DNP kernel server binded to PID equals false, then all we do, we return -EIO. Or is that the correct error code? Should we look for something more applicable? Perhaps. I need to work on improving this quality a little bit, to be honest. I hope it's not too difficult for you guys to see. Who here remembers when 316p was like the best thing ever? Just switching track, guys. So I'm just looking at error codes right now. So I'm just searching up error codes, guys, because I need to find the most applicable one. So you guys can't see that right now. As a matter of fact, I'm gonna switch my scene so you guys can see this. Okay, cool, right, that's fine. So let's take a look here then. Which one shall I go for? EIO is IO error. E again, E access. E-fault. No such device might apply to us, maybe. Although technically it's not a device. Invalid argument, no. File table overflow, no. Illegal seat, nah. Broken pipe. Broken pipe might apply to us, actually. But I think broken pipe is the winner. It sounds like it could. Protocol driver not attached. Yes. Yes, let's go for that. That sounds pretty applicable. Kind of. Although really it isn't the driver, right? Alright. Okay, cool. So let's just compile this a minute because I want to make sure this is right. PID mutex undeclared. Right, let's just look at that a minute. 126. Line 126. Why are you guys not seeing that? Alright, there you go. I gotta be careful not to close these prompts because every time I do, you guys can't see anymore. Ah, it's Pedlock. Pedlock, that's what it is. Pedlock. And you can see all this ISO C90 rubbish. Right, let's get that working properly. Right, I need to look this up because I'm not sure how to apply this to the kernel make file, to be honest with you. Right, alright, let's have a look. What else have we got here? See, this guy didn't answer the question. Oh, you guys can't see, I keep forgetting that. Anyway, he's at -6 downvotes for a stupid comment like that. Let's put this in. I just found this. There we go. Hopefully now these stupid warnings will go away. Yeah, kind of. No, didn't work. Line 77. Right, okay, I found this. Because to be honest with you, there's a reason why C++ doesn't care about that stuff. Because it's just stupid to even mention a warning. Because I haven't declared my variables at the top of the program, to be honest with you. It's like the old standard. Alright, let's go back here. So we're going to test this new functionality now where if we are not binded to that user socket, user server, whatever we'll call it, that user server. If we're not binded to that, then the kernel will reject any send messages requests. And that should work. Let's take a look at where is this gone now? Send message, yeah. DMP kernel server binded to PID. If that is false, we return EUN attach, EUN attach. So let's test if that works, guys, a minute. So we're going to insert the module. Alright, okay, right. So we insert the module, that's good. Let's demessage that shit. Alright, register protocol family 43, brilliant. Let's check if you guys can see. Yes, you can, brilliant. Right, so now, if I go, I'm not going to host it, right, because we want to see if there's an error message that gets sent back to us. So we're going to go to test2.c. Is this the correct script? Because I can never remember, to be honest. No, it isn't. Test.c, there she is, right. Alright, we run that now. And also, I want to get rid of this shit by here as well, because this is a load of rubbish. We're going to get rid of this, and we're going to include dmp shared.h. Alright, cool. And what I'm going to then do, this isn't a system library one we're doing. So now what I'm then going to do, I'm going to compile that. Making sure you guys can see. Yeah, good, good, good. So we go back, and we're going to compile that. test.c.o.test, and then we're going to set the include directory to kernel mod /Linux. DMP socket must deliver undeclared. First use this in a function test27. Oh yeah, okay, we don't need that rubbish there. Let's get rid of that. Let's try that again. Oh wait a minute, what's this now? Alright, we don't need that either. Get rid of this. Alright, we try that again. That compiles, brilliant. Now, this should give us an error if everything works, or it'll crash my machine. Let's see which one. Oh, nothing will happen. Nothing happened, okay. That was disappointing. Oh wait, no it did happen, I just didn't check the return. I didn't check what it returned, sorry. Alright, so we go in integer rc, and we go printf, and we're going to go pass an integer there. We're going to pass an rc there, brilliant. Let's try that again, gcc, yep, brilliant, test. -1 we receive, which is good because it failed. If it didn't return -1, I'd be surprised. But the -1 Linux error code is operation not permitted. So I guess it didn't give us as detailed as the message as I wanted, but that's fine, never mind. Now let's start the server, and we should not see -1 anymore. We should see 0 or a positive number, right? Let's check you guys can still see everything. Ah, and you missed that whole thing because this thing messed up. Brilliant. Alright, let me put that back. Let me connect that back on for you. Okay, so now let's do a recap of what I just did. We go gcc test.c, right, you guys can definitely see that now, good. So we compile that, we go .test, and it gives us a -1, which is an error, right? Because we print the RC by here, which is the return from send when the kernel gets back to us, right? Cool. Right, so what I need to do now is I need to start the server, and then we'll run that again, and then hopefully everything should be fine. So let's just make sure of that. So I'm going to control C this. Good. And one concern I have is you guys keep seeing the wrong window. Let me try and run that. I haven't done a setup like this before. Let's see what that is. DMP mod Linux. Alright, good there. I don't know why it's not refreshing. Alright, let's try this now then. So we're going to go back. And then we are going to... yeah, you guys can see perfectly now. We're going to go back. We're going to go to... I'm right here anyway. Okay, cool. We're going to go to bin, exe. We're going to go to bin. We're going to host this thing. There we are. Brilliant. That worked as expected. Now the next thing to do is to run that again. Can you guys see that? Yes, you can. Brilliant. We're going to run test, and we see a 0. Why do we see a 0? Because the kernel module is now binded to the local application. So we go here. DMP kernel server binding to PID, that returns if it's binded or not. And then we go here, send message. This thing here, if it is not binded, we can't continue because we're not doing all this heavy load in the kernel. That's a really bad idea. It could be dangerous. If we get if someone exploits our program, we are fucked, because then unfortunately they have access to the whole kernel. So we run everything in a user program, and once we run everything in a user program, then what we have is safety. So what they do is they bind to us through a netlink socket, and then anything sent to us through the driver, we then redirect to the user program where it handles it, right? That's the idea. I'm gonna listen to some rap while I do this now. So let's copy this.
Time at home and flying, split my life, working wife, getting paid is not a crime. Cruise chewing, never cheated, always beefing, getting heated. Not gonna listen to what I'm saying, look down and read it.
So what we're gonna do, we're gonna create a, let's change this song. We're gonna create a what am I trying to say now, because I'm getting confused. We're gonna create a definition for this to keep things clean and smooth, right? Alrighty, nice. Now if we can paste this straight in the code now, and it should be a bit cleaner. And it really should be as simple as that. So you can see we've basically changed how the language works, how C works by doing this, right? So, I mean, let me just make sure that compiles before I start getting excited about that, right? We need to go make Linux. Let me check you guys can see again. Yes, you can. Brilliant. I think I got that working properly now. Alright, so that works. That compiles. So now all we need to do is ensure kernel binded in all of these. So rather than these 3 lines of code, we reduce it to 1, making the code more efficient, cleaner. See how much easier that is. Alright, now for the hard stuff, we need to actually transfer this to the user client, which is going to be a bit difficult to do correctly. Well, let's see what we can do with that. First things first, we need to create a new package. We do this by modifying kernel mod shed, tmp mod shed. So you can see currently we support two types of packets, a hello packet and a hello response. So we're going to create another one in here. We're going to call it a datagram packet. And these datagrams will bounce all around the network until they are received by the recipient, if this goes to plan. We'll keep it simple for now. 1024 will be the maximum datagram packet size for now. Just because I know if we get too much higher than that, it becomes a bit difficult to transfer that data more reliably across the network. And I don't want to implement a stream protocol yet because it's harder. So we'll need to wait until we do that. Alright, that looks pretty fine. That should work okay. So what we need to do now is we actually need to set that data and send it, and it's just a char buffer, really, right? It's just an array of bytes. So how do we do this? We need to make these two functions available outside of this dmp kernel server.c file. So we do that by pasting these in here. Excellent. Now by pasting both of those there, we gain access outside, which is what we need. So how do we do this then? Well, we go here. First, just change the song. I need something a bit easy, a little easier to go with. So I'll go with this one. This is pretty lightweight, easy going. Right. Yeah. So we've exported those functions, which is excellent. Now we can actually send packets from the kernel to that attached process via netlink. So what we're going to do then, we're going to go to the datagram protocol. I don't think I need all of this, right? Now, I'm not completely sure. I don't think this is needed. I really don't. So we can get rid of all of this, I think. But I could be wrong, and if I'm wrong, we'll see a system crash, right? So that's fine. I don't think I'm wrong. Alright, so what we're going to do next is we're going to craft a packet, which we probably should kmalloc, because I don't know how much stack we actually have in the kernel. I don't know if it's a lot, so we're gonna kmalloc that. So that's another thing. Are we exporting DMP kernel packet? Doesn't look like. Hold on. Yeah, so we need to include DMP mod shared in this module. I can't wait until I can actually test this, right? Because I could literally go into a cafe. I could send a DMP packet to anyone on the network through ID, not IP address. And then what would happen is I wouldn't need a port forward or anything, and it would be delivered. It'd be pretty cool. There's so much potential for this type of these types of things. So we're going to go DMP kernel send packet, but first we need to craft the packet obviously, so let's do that first. We're going to go struct DMP kernel packet. Now we're going to mem set this thing completely to 0. And there we go, that is mem set to 0. Excellent. We could probably, make that a little simpler, to be honest with you, Like, it's a little, we're going to be repeating ourselves a lot doing that, right? But, for now that's fine. What we're going to do now is we're going to go packet.type. I'd love to make I might make a function for this, to be honest, that returns us a packet, but it's mem set to 0, because this is a bit silly. But never mind, there's just better ways. So we're going to go packet.type. As a matter of fact, let's do it. Let's keep it clean. So what we do next is they provide a type to us, and they also provide access to that packet, right? And now what we do is we go memset packet 0 size of DMP kernel packet. And there we go, look how much cleaner that is, right? So much cleaner, right? So now all we need to do is, as a matter of fact, we can make this even simpler. Even simpler, seriously, watch this, right? Let's make this cleaner again. So this is my attempt to make this even cleaner again. Watch this, define new kernel packet. New kernel packet, right? New kernel packet, new DMP kernel packet, to be precise. And then all we do here is we go struct DMP kernel packet. We need to accept a name. I hope I'm doing this right, because I actually can't remember the syntax for this, which is embarrassing. Anyway. Let's just try it. I might be really wrong, to be honest with you. So we're going to go struct DMP kernel packet name, which might be wrong, by the way, just bear that in mind. And then we're going to go, I think it is wrong actually. Never mind, we're going to try this anyway. Kernel server new packet, and then we're going to go yes, we're going to go type, and then we're going to go name, brilliant, and then type here will be set here. So let's just try this out, because I don't even know if this will compile right. I might have done it wrong, so admit my mistakes. Right, let's try this now. And if this works, then the code will be a bit cleaner. So we're going to go packet name, packet, type, DMP, kernel packet type datagram. Now if we try that might compile. Let's give it a go. Oh, I forgot the semicolon, guys. Alright, unfortunately I need to look this up. Can't believe I forgot how to do it. That's embarrassing. How could I forget something so simple? Let's just look this up, because I really can't remember how to do this. Oh, actually, this looks fine. The way I've done it. Hold on. Can't remember. Give me 1 second, guys. I know there's a way to do this. These guys are lying. You guys can't see what I'm looking at. 1 sec. Yeah, exactly. This should be fine. This should be fine. Pretty confused now. What's going on? Oh, what have I done? Alright, you know what, we'll come back to that, right? There's no need for that anyway. It just, I thought it'd be a nice little feature, to be honest with you. As a matter of fact, actually, let's peek into the module init function, because they probably do something similar. I'm looking this up because I want to know now, because I'm getting annoyed. I'm pretty sure I had this right. I must be so close, because I'm pretty sure what I did was correct. I'm really sure of it. Yeah, I'm looking this up now, and what I have done was correct, actually. It was correct, so I'm confused of why it didn't work for me. Very strange. Very, very strange. Should have worked. Yeah, I knew I had that right. So let's try and break this problem down a bit more, because I knew what I did was correct. You know, right? Let's first try and just get rid of this to begin with, and see if this compiles. No. Okay, let's get rid of this. Great, it wasn't even related to that. There we are. All right, we're back to a clean slate now. All right, let's get that back in. There we go. Let's semicolon that. I think I made a mistake halfway through the project, guys, and thought it was my code, but my code was fine. So that's fine, my code was correct. I just made a typo or something. But anyway, it's fixed now, right? Completely fixed. Alright, let's take new DMP kernel packet. And you can see how much cleaner that is by using a macro, right? Because now we can just say new DMP kernel packet, we pass the name, we pass that, and all that does is create a variable called packet that is of type struct DMP kernel packet, right? If I peek into there, watch this. You see that? Define new DMP kernel packet, name, type, struct DMP kernel packet name, DMP kernel server, new packet, type name. So then that basically it initializes it for us and defines it. So we can literally access this now like that, right? It might the IDE might not show us that we're doing that, but we are doing that, and it should work fine. Oh yeah, I gotta get rid of these strings a minute, I think. Oh yeah, and then we have an implicit declaration, which is something else. So let's go back to the dmp.h. And the reason that is happening is because we left it in this file. So this needs to be moved to the header so it can be accessed outside. Brilliant, brilliant, brilliant. That's correct. That'll work. Alright, DMP was compiled. There's one more mistake in this one. Incompiled type for argument 2 of DMP kernel server new packet. What is argument 2 accept? I think I put integer, that was the wrong one. I didn't put integer, I put that. Right, that's fine. In that case, I've made a mistake in the macro, no worries. What we needed to do instead was put a ampersand, which I completely forgot to do, which is fine. Just do that. Try that again. Okay, that was fine. That problem's now solved. Maybe not. We'll fix it. Look at that. I left that thing in the way. That's the problem there. Get rid of that. And there we go. I'm proud to say that compiles. Which is great. Well, we have a warning here. What's this? The frame size of 1040 bytes is larger than 1024. Alright, let's try and find out what that's about. Line 76. Oh, I know what I did wrong. My mistake, guys. I didn't declare it on the heap. That was a really stupid thing not to do. What we need to do, we need to go back to here. It needs to be created on the heap. If we don't create it on the heap, we're asking for trouble. So what I'm going to do instead is I'm going to go and do this. It's a nice simple chain. It's not that difficult, right? Equals malloc. And let's not forget that cast DMP kernel package malloc. And then we're going to go size of DMP struct DMP kernel packet, and that'll declare the memory for us. But then obviously I want a macro for free in that, right? So DMP free DMP kernel packet. Now really I don't need a macro for this, but the reason I'm using a macro is because I want to try and keep it I want to keep the same sort of code style. It's just cleaner, right? So we're going to go free name. And doing both of those things will result in this working correctly. Yes, it will.
We are stars falling from a dark night skies. A treasure reflecting traveling light. We are waves of
Alright, what's this? Implicit declaration. Oh shit. We're sorry, we are in the kernel. Why am I using malloc? Malloc is not available in the kernel. We should be using what was it? Calloc, I think. Is it Calloc? Let me have a look.
shining through the crowd. Even when it's darkest and so bright.
SKLoc, we don't want that. No, we want
Because you're beautiful. Even when it's hardest and so dark.
what was it called? I completely forgot. I think it was Calloc, was it? Let's have a look. K malloc and K free, that was it. Excellent, I'm happy with that.
Lights you up so tough.
K malloc and K free, and it's right there in my front of me and I didn't even notice.
Do you have this hold on me?
K malloc and K free will solve our problems.
I fall away at the seams, wings on your shoulders, an angel, a symphony of.
Alright, what has happened here? You guys have lost view. I hope that haven't been for too long. I hope not. Alright, let's make this. That's argument 2. From incompatible pointer type, that's fine. We'll fix that.
Lost inside this tidal wave of love. I'm underwater.
TMP kernel server new packet.
Breathing for the spark that's between us.
That takes DMP kernel packet.
Have you noticed?
Ah, now we no longer need the ampersand. My mistake. And kmalloc also requires an extra argument to specify where the access to the memory or something. Can't remember. Anyway, it's GFP user, we can use that. I don't remember exactly what that does. Maybe makes it... I can't remember the reason for that. I think it's to do with the memory access. Okay, GFP user, there we go. Let's make that now, and it compiles for the most part until we reach here. Too few arguments again. Ah. Where did I add that to? Oh, that's the correct thing. Let's just right click save all a minute. Try that again. Yeah, there we are, perfect. And then we go back to the datagram protocol. And there we are. I know I wasted a bit of time, but it is cleaner and it compiles. Number 90, the frame size is longer. Okay, let's have a look at 90. Give me one moment, guys. Let's see what's causing that error, because that's quite a serious problem right there. We can't be exceeding the SAC or leads to undefined behavior, right? It's dangerous. Oh, that's in the DMP kernel server. I'm looking in the wrong file, guys. Sorry. DMP kernel server line 90. Alright, yeah, I see the problem here. It's not too bad, right? We just need to change the way we access this to use our new functionality. So we're going to go DMP create kernel packet. Why does this keep happening for you guys? I've locked that now, so hopefully now it won't move. It's really annoying that keeps happening for you guys, because I can't show you what I need to see when it locks the entire window. I've locked all the components now, so they're non-movable. Hopefully now that makes it much more clear. Alright, let's see how that looks now. That prompt is basically impossible to read. And I know why, because it's larger, right? You know, I gotta get used to this, guys, this new streaming thing that I'm doing, because what's happening is I'm forgetting that you guys can see these changes that I make to the window, and if I make it too large, you guys can't see anything. So this might have ruined the whole stream, to be honest with you. But I don't want it getting too large, you see. If it gets too large, then we have a problem, right? Anyway, let me shrink the window again, back to what I want it to be. I'm going to try and resize it again, because you guys can't see anything with that text being that small, right? I know I should have done this earlier, but I haven't made the stream like this before. I've always allowed you to see everything. God. Why doesn't it work? It's just ridiculous that it resizes it like that, honestly. When I resize the window, it resizes it for you guys too, rather than just scale it like a normal thing. That's really annoying, that is. God. I just need to try and remember not to scale the windows for now. Alright, let's keep going. Alright, so what we need to do is back to where we were then. Where were we actually? I forgot. Oh yeah, we're fixing this problem, which I've just forgotten what it was. Oh yeah, I remember again. Yeah, okay, so we go down here. We need to go dmp.h. And we're gonna grab this, we're gonna chuck this here. And that should be the fix. Let's compile that again. We haven't included the header file. And it requires 2 arguments, which I forgot. And there we are, DMP kernel hello response. We don't need this here anymore. See, so it's cleaner, kind of. Right? Encapsulating it like that makes it a bit easier to read. And then obviously we can't access it as if we're in a stack anymore, because we're exceeding the stack. Passing argument 1 from incompatible pointer type, that is fine. Not a problem. Let's see what I did. Of course, it's that. There we are. Get rid of the ampersand. It should work now. Compiled, yes. Brilliant. And you guys can't even see the code again because I've extended the actual window. I gotta stop doing that. Why do I keep doing that? Is there a way to lock this, yeah? Way to lock this window? Don't know. I swear, guys, I'm gonna fix all of these problems with this stream before I stream next, because I've had quality problems, everything, because I'm not used to streaming. I'm not used to streaming, to be honest. I just start the stream usually. I need to focus more on improving the video quality. Right, let's where were we? Where were we? I forgot. Oh yeah, we're down here, right? Yeah, I think. Ah, there we are. This is it. That's a good tune. Okay, excellent. So what do we do now, you ask? Well, we need to finally send that packet. Finally here. Excellent. So we're going to mem copy everything into here, right? And that will work. That'll work just fine. So IOV equals message iterator IOV. That can be one line. Cleaner. So that'll that should work just fine now. We grab the message and then we go get the base and the length and we copy all that data across to our datagram packet. Then we send that to the clients. Now if that fails, which it might, we need to handle that gracefully. So it returns an RES, so that's fine. If it's below 0, there's a problem, I think. I need to double check that though. Let's check that now. Okay, this returns a 0 on an error. No, it doesn't. Sorry, it doesn't. It returns 0 on success. And then if it's below 0, it's an error, right? Alright, so if we fail to send the packet, what do we return? Well, an IO error, I guess. Does that sound correct? Let's have a look. It might make sense to IO error. I'm just looking at some. I'm gonna switch my my view. There you go. You guys can see everything now. So I'm looking through these error codes. Which one counts to us? Well, remote IO error makes a bit sense, I guess, because we're accessing a program, but I think that means more network stuff. Protocol not available. Now that could work. Now protocol not supported is incorrect because we are supported. Protocol not available, however, means it isn't available this time, right? So that could be something good to pass. A pipe error makes more sense, I think. Protocol error, nah, because that implies there's something wrong with the formatting, right? The machine is not on the network. Maybe. Probably not. Yeah, they got a lot of good things. Communication error on send. There we are. So you see, that's applicable, right? Absolutely. Minus econ. And let's put you guys back to the other one. Cool. So I'm trying to be as descriptive as I can with this. So failed to send kernel server packet to kernel server, has it crashed? Question mark. That's nice and descriptive. So if anyone's wondering why this is not working, hints them to check for this, right? So that's a communication error. That's fine. And now we can test that. I think. Let's go to first. Let's compile the module. Oh right, shit. Hold on, I need to put an ampersand there, guys. I think. Okay, that worked fine. Ah, one other thing I forgot. I'll pass that in there. Let's change this song. Half decent, but it's too much. Alright, what I'm going to do next. DMP kernel server send packet. Failed to send packet. Has it crashed? It's a good point. Has it crashed? Alright, let's just try one more thing. That compiled now, didn't it? And I did it again. Really sorry, guys. So we're going to go to receive packet now, RECV packet, and yeah, by here on this thread, we basically want to receive these things constantly, right? So what we're going to do, we're just going to say receive packet. First we're going to create this. And we can be as greedy as we want here because we're in user land, so I think we got quite a lot of stack space. Obviously maybe it should be on the heap as well, but I think this is appropriate. So we're going to go receive packet. Ampersand. No, we don't need an ampersand, that's fine. So receive packet, and then we're going to go if packet dot type equals DMP packet type datagram, and watch this, we're going to go cout packet. Now if this works, guys, I'm over the moon, because then I can start some really proper stuff later on tomorrow or throughout the week. Some seriously good stuff. Alright, let's try this. So what we're gonna do, we're gonna firstly check you guys can see everything good. Yeah, we're gonna initialize the mod. Shit is in use, give me a sec. We control C that one, and then we can remove it, we can unzip, we can host it, good, and then once we've done all of that, I'm just going to put sub wrap on before I come off, guys. Give me a sec. I'm going to do a bit more work first, obviously. What's this? Mother Teresa verse. Yeah, what's this? Failed to host. Okay, let's find out why. That's all fine. I see what's happening, guys. Sorry about this. Right. Basically, we need to catch this because it does not like when we it doesn't like when it times out.
But that's enough about Mary B. Let's turn to my favorite subject, me. I got mouth cancer, wasn't feeling so hot. Had the doc put me down with a morphine shot. Think imaginary God, I wasn't in one of your beds. You'd have just sprinkled magic water on my forehead. I help people live, you watch people die. To get souls for a man in the sky. You took credits that you didn't deserve. You're the fakest sister act since Whoopi Goldberg. You were running Project Pimps and Projects. To you, Calcutta meant Calcutta. I can see right through you and you've got no flavor. I'm battling a communion wafer.
You call that a verse? You're super ego tripping. I gotta say, Sigmund, you're Freudian slipping. I built mad missions in my savior's name. All you built was a mad tolerance for cocaine. Obsessed with masturbation, but you're off the beat. Your flows are so poor, I should be washing their feet. Dreams are the only place you'll ever be as dope as me. I make my rhymes count like beads on a rose. Everything is sex to you after I'm through wrecking you. I'll have to go and do confession just for standing next to you. You want the second coming? I'll bless the mic again. I end you like a prayer, mother lover, amen.
I noticed that you talk a lot about your.
Alright, that's fine. Oh shit. Okay, I forgot to compile it.
People's money. Ooh, an exception to my theory. I can't believe this. Here we have a mother that no one wants to sleep with. You had a nice message, but your methods were detestable. I've seen better care given to organic vegetables. All these tokens and smoke and miracles. You really believe all this stuff? You're hysterical. I've got the libido to continue to beat ya. But our time is up, Teresa.
Hold war! Holster!
Oh, it's segfaulted. See, it's never fun when something segfaults. That's never fun, right? Let's just make all. There's no kernel problem, right? Hope not. Alright, let's find out why. Line 47. Line 47. Bind socket. Line 47, it breaks. What the shit am I, why? Oh no. Nah, that's just... Right, we're gonna call it here because I'm getting really sleepy and making mistakes. Basically seg faults, which isn't good. We'll fix that soon, but one step closer. See you guys.